Thousands of tons of timber, 100-ton machines, and just a matter of seconds for a massive ancient tree to be turned into finished lumber. These are the largest sawmills in North America, where every single step, from unloading and sorting to sawing and cutting, is executed with mind-blowing speed and precision. Today, join RaWMachines as we go inside this massive facility to see what exciting things await. Located on the shores of Adams Lake near the town of Chase, British Columbia, Interfor's sawmill receives a massive volume of logs every day to keep its production lines running. However, the logs arriving at the mill are not always harvested nearby. Many shipments come from forests deep in British Columbia's interior, where the landscape is divided by lakes, valleys, and rugged mountain ranges. In these remote areas, distance is only part of the challenge. Steep terrain, long logging roads, and constantly changing weather conditions make it difficult to transport all the timber by truck alone. Instead of requiring every load of logs to travel the entire route by road, the industry takes advantage of Adams Lake itself as a natural transportation corridor. At the log loading dock, powerful log loaders equipped with hydraulic grapples work continuously, lifting massive bundles of logs onto waiting barges. Loading isn't simply a matter of stacking as much timber as possible. Each bundle must be aligned in the same direction and distributed evenly across the barge to keep its center of gravity stable throughout the journey across the lake. Once the barge is fully loaded, a tugboat moves into position, secures the tow line, and slowly pulls the entire convoy away from the dock.
It might be at the bow.
At the receiving area, the logs aren't lifted directly onto shore. Instead, the barge slowly tilts, releasing its entire load into the water. At first glance, the scene looks chaotic, but in reality, every step is carefully engineered.
Yeah, baby.
Unloading the logs one bundle at a time with cranes would take far too long. By using a water-based receiving system instead, the mill can unload massive volumes of timber in a fraction of the time. Once the barge departs, a small boom boat immediately takes over. Amid the floating mass of logs, it gathers those that have drifted apart, aligns them in the same direction, and pushes the entire flow of timber toward the mill's log pond. The log pond serves as a natural raw material storage yard. Here, thousands of logs are kept afloat and ready to supply the production line whenever needed. When the mill requires more raw material, the boom boat delivers another batch of logs to the Infeed system. A massive chain conveyor then lifts each log out of the water one by one, aligns it, and feeds it deeper into the mill for processing.
Look at that. Look at the jaws before it goes in. Come on down.
Yeah.
At Interfor, debarking is the very first process every log goes through. Amid the high-pitched screech of steel rollers, the rough outer bark is stripped away, revealing the pale wood beneath, raw, pure, and untouched. After debarking, the logs are transferred from the log deck to the primary breakdown saw. Along the way, an optimization scanning system analyzes each log from end to end to determine the most efficient cutting pattern. The data is then sent directly to the saw, where each log is cut into a cant or into 2 and 3 or 4-sided pieces. From these cants, the high-speed production line continues sawing and milling them into lumber. Each board is then edged, trimmed to length, and graded before moving on to the finishing stage. Notably, every byproduct, including bark, sawdust, wood chips, and residual wood waste, is collected for resale or used as fuel to power the kiln drying system. The final stages consist of drying, planing, and packaging. Since freshly cut lumber has a high moisture content, it must be dried to increase stability and minimize warping. Afterward, the lumber is planed to smooth the surface and achieve uniform width and thickness. Once these steps are complete, the boards are ready to be packaged and shipped. To meet the diverse needs of its customers, lumber is produced in a wide range of quality grades. Each board is carefully inspected, graded, and stamped before being sorted by size and quality for packaging. Finally, the finished products are stored in the lumber yard before being shipped by truck or rail to customers across North America and around the world. Behind this advanced production line is the dedication of the people who keep it running. One employee shared that while the job requires flexibility and can be demanding at times, the supportive work environment, along with great coworkers and management, makes every effort worthwhile. For them, the most rewarding moment is seeing the finished lumber stacked in the yard and knowing they played a part in bringing it to life. Our journey at Interfor comes to an end as we arrive at our second mill, Collins Lumber. Founded in 1855, Collins is one of the oldest and most influential companies in the American lumber industry. Every truckload of logs entering the mill passes over an electronic truck scale. Within seconds, the vehicle's weight is recorded with precision, helping the mill monitor incoming raw materials and plan production for each shift. After weighing, hydraulic loaders unload the logs from the trucks and place them onto the log deck. From there, the logs enter the production line, beginning their transformation from raw timber into lumber for the construction and furniture industries. The first stop for large diameter logs is the head rig, the machine responsible for the most critical cuts in the entire production line. Rather than relying on brute force, the head rig uses a multi-point laser scanning system to read each log in an instant, calculating the optimal cutting strategy to maximize yield. The first cuts remove the outer slabs from both sides of the log, while the center section is retained as a cant, the primary material for the next stages of processing. For smaller logs, Collins utilizes a single-pass saw. True to its name, the entire sawing process occurs in just a single pass through the machine. Within seconds, the log is ripped into multiple parallel boards of virtually uniform size. Minimizing the number of handling steps not only boosts productivity, but also reduces material waste, a critical factor in modern wood processing. After the initial breakdown, the slabs still contain a significant amount of usable wood. Rather than treating them as waste, Collins feeds every slab into the resaw system, where the outer pieces are cut into thinner boards to maximize the value of every inch of timber. Meanwhile, the cants move on to an entirely different stage, one where technology truly demonstrates its advantage: the curved gang saw. Unlike conventional saws, a curved sawing system is designed to follow the natural curvature of the log. First, sensors scan the entire log to generate a 3D map. Based on this, algorithms calculate the optimal cutting path, ensuring each cut closely follows the natural grain structure of the wood. During operation, the log is guided through a series of rollers that can pivot and tilt in multiple directions. At the same time, the saw blades are mounted on a flexible mechanism, allowing them to shift angles and bend along the predetermined curve. Spinning at ultra-high speeds, the thin saw blades glide through the wood with decisive precision, producing a smooth surface while minimizing micro cracks. The entire process is so seamless that it feels as though the blades are listening to the very grain of the wood. As a result, lumber recovery is typically 10% to 15% higher compared to traditional sawing technologies. Leaving the curb saw, the boards still have wane, curved edges that follow the natural shape of the log. The edger removes these outer edges to create straight, dimensioned sides. A laser system scans each board, determining the optimal cutting path, before twin saw blades simultaneously rip down both edges. The result is perfectly sized boards with straight edges, maximizing the yield of high-value wood. Once edged, the boards move on to the trimmer to be cut to standard lengths. This line features dozens of saw blades spaced about 2 feet apart. As each board passes through, the system automatically determines its optimal length and drops only the necessary blades to yield a standard grade product with minimal waste. While the majority of the process is automated, the human element remains vital. Operators continuously monitor each cut, inspect equipment performance, and ensure every piece of lumber meets quality standards before advancing to the next stage. After being precision machined, the boards continue along steel conveyors to the sorting and kiln drying area. Here, the automated sorter takes over. Each board is lifted, rotated into the correct orientation, and placed into the appropriate bin based on its size, length, and thickness. Once a bin is full, the stacker begins assembling the boards into bundles. Spacer sticks are placed between every layer, creating airflow channels that allow heat and air to circulate evenly throughout the kiln drying process. This is perhaps the quietest moment in the entire production line. After the sharp, relentless sound of the saws, only the steady hum of compressed air remains. A slow, rhythmic breath before the lumber enters the kiln. This is the decisive structural stabilization stage, where the wood sheds its excess lifeblood, the remaining sap and moisture, to achieve a state of lasting stability, resilient against any weather conditions. Here, a sophisticated control system maintains absolute control over three key variables: temperature, humidity, and time. Guided by real-time monitoring sensors, the kiln drying process is calibrated down to the exact minute, preventing the lumber from cracking, checking, or warping. The result is lumber that is lighter, stronger, and structurally rock solid, ready to enter people's lives with a promise of enduring quality. After kiln drying, the boards pass through a high-speed planer, which smooths the surface and brings every piece to its precise finished dimensions, with uniform thickness and clean, sharp edges. Next comes the grading stage, where advanced technology and human expertise work side by side. Industrial cameras and machine learning algorithms can identify more than 70 different types of defects, while experienced graders perform a final inspection to verify the quality of every board. Boards that meet the required standards receive a grade stamp before leaving the production line. More than just a mark from the mill, the grade stamp is a certification of quality, giving customers confidence that every board meets established standards before it is used in construction projects or crafted into furniture. In the final stage, boards of the same dimensions and grade are bundled together, secured with steel straps, and labeled with the mill's identification tag. Forklifts then transport the bundles to the storage yard or loading area, where they are prepared for shipment by truck and rail to customers across the United States and international markets. From here, each bundle begins a new journey, becoming the framework of a home, hardwood flooring, furniture, or countless other products that people use every day. For Collins Lumber, the production process ends when these bundles leave the mill. But for every piece of lumber, it marks the beginning of a new life, one where the value created by nature, advanced technology, and skilled craftsmanship will continue to take shape in homes, buildings, and everyday spaces for decades to come. If Interfor and Collins Lumber stand as icons of the North, our journey now leads us south to Colum's Lumber Products. From a humble planing mill founded in the 1930s, it has evolved into a world-class manufacturing operation without ever losing sight of its core philosophy: honoring the wood, valuing its people, and preserving the spirit of the forest. In front of the plant is a vast storage yard where thousands of logs are gathered and stored before entering production. This area can be seen as a raw material bank, ensuring the production line always has enough timber to operate continuously, regardless of logging conditions or external weather. According to each shift's production plan, a hydraulic crane picks up the logs one by one from the yard and places them onto the log deck. From here, the logs are steadily fed into the line, kicking off a processing sequence executed with near absolute precision. The plant's debarker operates like a massive, continuously rotating steel drum. As the logs roll through, the rough bark is quickly stripped away. The bark falling onto the conveyor belt below is never wasted. Instead, it is collected to produce biomass fuel or processed into landscaping mulch. Immediately after, the merchandiser system uses 3D laser scanning to read every millimeter of the log's curvature and defects. Artificial intelligence then suggests the optimal processing plan. The highest quality logs are designated for utility poles or purlins, while the remainder is allocated for standard lumber. Even though the system calculates at lightning speed, the final decision still rests with the operator. It is this combination of AI and real-world experience that allows Colum's Lumber to maximize the yield of every single log before it enters the sawing stage. Leaving the laser brain checkpoint, the most massive logs are directed to the carriage saw line. Here, the log is secured onto a carriage while a system of lasers and sensors scans its entire shape, diameter, and sweep. Based on this data, the computer calculates the optimal cutting pattern to maximize lumber recovery, while preserving the natural grain structure of the wood. As the carriage feeds the log through the primary head saw, the outer slabs are removed from both sides, while the center core becomes a cant. The slabs are routed to the resaw to recover additional lumber, while the cants are sent to the curve gang saw for further processing. This flow management allows the plant to utilize over 90% of the valuable wood from each log. Meanwhile, logs with small to medium diameters are processed on the reducer twin saw line, a high-speed production line built for maximum automation. The process begins with twin chip heads that flatten two opposite sides of each log, while simultaneously producing wood chips for use in other industries. Next, a vertical saw splits the log's core, after which automated handling systems rotate and reposition the cant for the next stage of processing. The sideboards are separated directly on the line, while the remaining cant is transferred to the curve saw gang for the final sawing operations. Like many modern sawmills, Colum's lumber doesn't force every log through a rigid cutting pattern. Instead, the entire production line is engineered to adapt to the natural shape and curvature of each log, maximizing both lumber recovery and product quality. After leaving the primary saw lines, the boards are routed through the edger system to remove any remaining waney edges, creating two straight and uniform sides. Next, the trimmer cuts the boards to standard lengths based on the pre-calculated computer patterns. Throughout this entire process, industrial cameras continuously compare each board against design data, while operators monitor the line to promptly handle any exceptional cases, ensuring every product meets requirements before moving on to the sorting stage. Once the lumber has been cut to its final dimensions, it moves to the automated sorter, a tireless inspector that evaluates every board with remarkable precision. The system measures each board's thickness, width, and even density, directing it into one of more than 40 sorting bins. This is more than simple mechanical sorting. It's a way of understanding the unique characteristics of every piece of lumber, so it can be matched with the right value stream. When a bin reaches its target volume, the stacker automatically arranges the boards into neat, uniform bundles with exceptional accuracy. Between each layer, the machine places stickers, thin spacer strips that allow heated air to circulate evenly during kiln drying. This ensures the entire stack dries uniformly while minimizing warping and distortion. Finally, forklifts transport the stacked lumber to the kiln drying area. From sorting and stacking to material handling, the entire process runs continuously and is almost fully automated, enabling the mill to maintain high productivity while minimizing errors. Once neatly stacked and bundled, the lumber packages enter their toughest challenge, the drying kilns. Here, under temperatures of 70 to 90 degrees Celsius and a continuous circulation of hot air, the wood gradually sheds its excess moisture and sap to achieve a stable and durable state. This process demands absolute precision and patience, with sensors continuously monitoring the moisture content. Each wood species requires its own specific drying schedule. Southern yellow pine takes about 48 hours, Douglas fir 72 hours, while white oak needs up to 5 days to fully stabilize its internal structure. Upon reaching an ideal moisture content of around 15%, the wood becomes lighter, stronger, and highly resistant to weather fluctuations. From this stage, the lumber is ready for export, destined to become premium building materials in sustainable construction projects. The journey at Column's lumber products never truly ends with a bundle of finished lumber. Even after the finest boards leave the mill, its true spirit lives on through a proud, continuous cycle built on one guiding principle: zero waste. Here, the very idea of waste has long since disappeared, replaced by a deep respect for every part of the tree. Bark is given a second life as landscape mulch, protecting and enriching soil in agriculture and landscaping. wood chips become valuable raw material for the pulp and paper industry. Sawdust is compressed into high-energy biomass pellets, which in turn fuel the mill's own kilns, creating a closed-loop system where every byproduct powers the next stage of production. Since the 1930s, Colum has followed this path not only to maximize efficiency, but also to honor a lasting commitment to sustainability. Because at the heart of the mill, true value is measured not by how quickly timber is harvested, but by how responsibly every part of the forest's gift is preserved, renewed, and put to meaningful use. As the sun begins to set, warm plumes of steam continue to rise from the kilns, drifting into the fading light. In that moment, Colum's lumber products no longer feels like a factory. It feels like a living organism, breathing with the forest itself, drawing life from the woods and giving back sustainability. From vast forests to some of the most advanced sawmills in North America, every stop along this journey has revealed a different approach. Yet, they all share the same purpose: maximizing the value of nature through the precision of technology and the expertise of skilled people. We've witnessed machines weighing hundreds of tons bringing down towering trees deep within the forest. We've seen laser scanners and 3D imaging systems analyze every curve and grain of a log in a matter of seconds. We've followed production lines where sawing, drying, planing, and grading operate around the clock with extraordinary precision, where every cut is carefully calculated to recover the greatest possible yield while minimizing waste. Yet the most remarkable achievement isn't the size of the machinery or the speed of the production lines. It's the industry's ability to utilize nearly every part of the tree. Lumber becomes the framework of homes and buildings. Bark and sawdust are transformed into biomass fuel and wood pellets. Even materials once considered worthless are recycled into new products, ensuring that almost nothing goes to waste. At every mill, we've also discovered a philosophy that is reshaping the modern wood industry. Automation is not designed to replace people. It is designed to help people make better decisions. Computers can process millions of calculations every second, but the knowledge and experience of skilled operators remain the final guarantee that every board meets the highest standards before leaving the mill. Perhaps that's why the journey of a tree has never been just a story about massive machines or state-of-the-art factories. It is also the story of humanity's relentless pursuit of better technology, using natural resources more efficiently, reducing waste, and creating more sustainable products for future generations. From the forest to the construction site, from nature to the homes we live in, every piece of lumber is the result of an intricate process where nature, engineering, and human ingenuity come together to create lasting value. Thank you for joining RaWMachines on this journey through the modern wood industry. If you enjoy exploring large-scale manufacturing, incredible machinery, and the transformation of natural materials into finished products, be sure to subscribe so you don't miss our upcoming episodes. Until next time, we'll continue opening the door to some of the world's most remarkable engineering and manufacturing processes. See you on our next adventure.